Welcome to video 9.3b. Now we'll do some applications for the altitude and the hypotenuse theorems. Once again, all you need to know is leg squared equals near times whole, and altitude squared equals part times part. I'm going to do a few of the problems from your examples in your notebook. Your homework will be to finish the rest. I strongly suggest you use a pencil and mark up the drawings, then erase them, because you're just going to have one drawing for several problems, and it's just visually easy to write the numbers in so your brain can see what's going on. Okay, so example 1a. All of these involve altitude and the hypotenuse. So I put a question mark by what I was trying to find, and I put in the numbers by what I was given. So if you want, you can introduce variables x and y as needed. So I'll just call this variable x. I'll notice what I'm looking for is an altitude. So I'm going to go over here. Altitude squared equals part times part. So I'll simply say x squared equals 4 times 16. X squared equals 64. Take the square root of each side. I'm not going to do plus or minus because I can't have a negative altitude. So x equals 8. And then they actually asked for CD, so CD equals 8. It's always a good idea to solve for your variable and then make sure that you answer the question, just like we've been doing all year long. All right, 1b. All right, the question mark is over here. That's a leg. So I might be using this formula over here. Once again, I'll just call that leg x. So leg squared equals near times whole. So x squared equals 4 times 9. X squared equals 36. Take the square root of each side. Again, I can't have a negative side length. So x equals 6. Again, they didn't ask for x, they asked for BC. So BC equals 6. Okay, those were pretty straightforward. These two examples will require a little bit more work. So now I'm jumping to example 1i, and this is the information I'm given. So I'm looking for the altitude. However, I don't have the two parts. So what I'm going to do is an intermediate step to try to find them. So notice I am given a leg. So I'm going to do some work over here, get a part, and then work on the altitude. So what I'm going to do is I'm going to call this y just from there to there. I'm putting the y there on the near side so I can more easily use that formula. So just to show you, I'm going to use leg squared equals near times whole, or in this case, 4 squared equals y times 8. 16 equals 8y. Y equals 2. That's not what I was looking for. This is an intermediate step. So y is 2. Well, if that's 2 and the whole thing is 8, this must be 6. Now that I've got my parts, I can go ahead and find the altitude. I'll call this x. Make sure you use a different variable so it's not confusing. And now I'm going to say altitude squared equals part times part, or x squared equals 6 times 2. X squared equals 12. X equals the square root of 12. Again, always simplified exact answers. That's the same thing as a square root of 4 times the square root of 3, which is really 2 radical 3. Again, they didn't ask for x, they asked for CD, so I'll rewrite my answer. CD equals 2 radical 3. So that's an example of where you got to do an intermediate step. All right, this is example 2f, different picture, again, using pencil so you can erase. We're trying to find that dimension there. All right, so I've got a leg here. So maybe I could use this formula over here. Why don't I just call this, I can call this x. Now, once I solve for x, if I want to find this whole length, hopefully you can figure out it'll just be x plus 24. So once I find x, I'm almost done. All right, so let's write down the formula. So leg squared equals near times whole. And again, whenever you're setting up variables, if you have a choice, if you got a leg, put your variable by the near side. It just makes your work easier. All right, so 9 squared equals near x times the whole. This is confusing. It's not 24, it's x plus 24. That's the source of several mistakes. X plus 24. Okay, I'll just evaluate that, distribute. So 81 equals x squared plus 24x. Now we're going to go back to standard form, see if we can factor it. So I've got x squared plus 24x minus 81 equals 0. So I'm looking for two numbers that have a product of that and result in a sum of that. So 81 I happen to know is 3 by 3 by 3 by 3, or 3 by 27 is something that I can figure out easily, and 3 and 27 will work out nicely. So it's going to have to be a mixture of signs. So x plus 27 times x minus 3 equals 0. We could do our OI check. That's a minus 3x. That's a plus 27x. And that does sum 24x. And then we're going to chunk each factor and set it equal to 0. I could do that in my head. X could be negative 27. I can't have a negative side length, so I'll just write down my answer. So x equals negative 27, or x equals positive 3. I'm discarding that one because it does not make sense. Let's see if x equals 3 makes sense. Yes. Now, again, answer the question. They don't care about x. They really wanted rs. So rs will be 3 plus 24, or rs will be 27. And once again, use a pencil, keep erasing your numbers, and just these are the only two formulas you'll need, along with some basic math computations. So there you have it, some applications of the altitude and hypotenuse theorems.